Problem number 14. Suppose the line y is equal to 3 is a horizontal asymptote for f. Which of the following statements must be true? It's like all that applies. So let me actually draw something here. So horizontal asymptote. So the idea here is, here's like y is equal to 3, and we have a function that, you know, like our graph is looking like this, or, you know, something like that. This is an example of, you know, like the horizontal asymptote at y is equal to 3. So let's kind of work by process of elimination here. So the first one is that f of x is not equal to 3 for all x in the domain of f. We can actually see from this graph right here that, you know, right there, at this x value, f of x is equal to 3. So A doesn't make sense. A doesn't work. And for B, f of 3 is undefined. Well, this is actually kind of barking up the wrong tree here. You might think if it was a horizontal asymptote, we might think that there would be a problem with f of 3 being defined. Maybe f of 3 should be undefined. But when we're dealing with horizontal asymptotes, there's nothing at all here about f of 3 being undefined. So we can cancel out A, cancel out B. Those can't be right. The third one, the limit as x goes to 3 of f of x equals infinity. So once again, that would be something like a vertical asymptote. So limit as x goes to 3 of f of x is equal to infinity. That gives you a vertical asymptote at x equals 3. That's not a horizontal asymptote. So far, A, B, and C all are incorrect answers. So finally, limit as x goes to infinity of f of x is equal to 3. So this actually gives us, for the first time, something that is more relevant here. So, you know, here's a function, y is equal to f of x here. And from this graph, we can see the limit as x goes to infinity of f of x does equal 3, and that does give us a horizontal asymptote at y is equal to 3. However, the problem says which of the following statements must be true. And so let me draw one more example here, one more picture. And the picture is going to look like this. So here's our asymptote, y is equal to 3. And our function is going to look like this. So here, what we can see is that the limit as x goes to negative infinity of f of x is equal to 3. And that gives us our horizontal asymptote. But the limit as x goes to infinity of, of f of x, the limit x goes to positive infinity, I should emphasize the positive there, is negative infinity. And so in this case here, we are not guaranteed to have the limit as x goes to infinity of f of x equals 3. This does not need to be true. So actually A, B, C, and D, none of those must be true. So the correct answer is none of the above. So I guess the summary, what's the points here? Number one, don't get tripped up on the vertical asymptote versus horizontal asymptote. And then just remember, horizontal asymptote means that either the limit as x goes to infinity f of x is a constant, or the limit x goes to infinity, you know, of f of x is a constant here. So you can have either going to negative x goes to negative infinity or positive infinity. So you can have, you don't need to have the limit as x goes to infinity to be a constant. Instead, you can get an asymptote by just having the limit as x goes to negative infinity to be a constant. Okay, let's move on to problem 15. So here we are being asked about the following function, x plus a times x minus 3 over x minus 2 times x plus 1. So the first part of this, we're being asked for, and I should note here, a is a positive constant. Okay, so the first thing we're being asked about is the limit as x goes to 0 of this expression. So we should always think about what happens if we just directly plug in 0 by doing substitution. And here we can get away with plugging in. There's nothing bad that happens. And so we'd end up with 0 plus a times 0 minus 3 over 0 minus 2 times 0 plus 1. We're not dividing by 0 or anything. And this ends up as negative 3a over negative 2, or 3/2 a. So that is part A. For part B, x plus a, let me just recopy this all here down again. The limit as x goes to 2 from the left. So now we have to think about things a little bit more carefully, because when we plug in 2, we're going to get 0 down here. We plug in 2, okay, that's just going to be 3. We plug in 2 into either of these two terms in the numerator. 2 minus 3 is negative 1. That's not 0. 2 plus a, realize here that a is positive, so 2 plus a can't equal 0. You could say, oh, well, what happens if a is negative 2? And then those two factors will cancel. Then those two factors cancel, but a is not allowed to be negative 2. So we're going to have something not 0 over something 0. And so this is going to be an infinite limit. So in one sense, we could just say the limit does not exist. So, this is one case for saying does not exist. But if we want to be, I should say, for part C and part D, again, you're going to have D and E for that reason, if you're saying infinite limits don't exist. But if we do want to use plus or minus infinity, let's analyze what's going on here. So as x gets close to 2, let's see here, x minus 3 gets close to negative 1. So that term will be negative. As x gets close to 2, this goes to 2 plus a, that's going to be positive. As x gets close to 2, this gets close to 2 plus 1, that's positive. And now, this is going to get close to 0, but we should ask ourselves, is it going to get close to 0 for numbers a little bit less than 0, or get close to 0 for numbers a little bit bigger than 0? So if x is going to 2 from the left, the numbers that we're plugging in are like 1.9, 1.99, 1.999. And if you're doing 1.9 minus 2, you're getting negative 0.1. If you're doing 1.99 minus 2, you're getting negative 0.01. If you're plugging in numbers a little bit less than 2 here, you're going to get something negative. So positive times negative is negative, divided by negative times positive. Negative divided by negative gives us something positive. So this is going to be an infinite limit. The limit as x goes to 2 from the left of this expression is going to be positive infinity. So now let's take a look at part C then. Same function. Same function, but now we're doing the limit as x goes to 2 from the right. So as x gets close to 2 from the right, x plus a, that's still going to be positive. X minus 3, that's still going to be negative. X plus 1, that's still going to be positive. But now we're plugging in numbers that are like 2.1, 2.01, 2.001. And so when we're doing those numbers minus 2, we're getting like 0.1, 0.01, 0.001. Those are all positive. So again, we're going to have something not 0 in the numerator divided by something 0. The limit of this is going to be 0. So again, it's going to be infinite limit here, but now it's going to be negative or positive. This is going to equal negative infinity. And for part D, it says that what's the limit as x goes to 2 of x plus a times x minus 3 over x minus 2 times x plus 1. Well, that's the two one-sided limits here. One is infinity, one is negative infinity. Those do not agree. So the answer here is does not exist. Okay, so that is problem 15.